So let's talk a little bit about expected value, variance, and standard deviation. So above here, you will see the properties of expected value and variance and standard deviation that we spoke in class, and also along with the formulas. So what we're going to do is we're going to do a quick example. So if you want to pause the video, you can just write the top part above this line. It should be in your notes, but if you need to write it again, just go ahead and do it. So we're going to do this problem first. So given this probability distribution, so x can take on the values of 1, 3, and 5, and the probabilities in this case would be 0.3, 0.5, and 0.2. So if you add up the probabilities, it shows that it actually is a probability distribution. So the first thing is that we want to find the expected value of x. So there's nothing really to this. All we just got to do, I'm just going to write it mu, which is equal to the expected value of x. This is just going to be equal to multiplying the sum of the multiplication of the probabilities times the x value. So I'm going to take every x value, 1, 3, and 5, and I'm going to multiply by their respective probabilities. So here's going to be 0.3, here's going to be 0.5, and here's going to be 0.2. Okay, so I'm going to use my calculator to plug all of these things in. So if I were to multiply all this, here I'm going to get 0.3, here I'm going to get 1.5, and here I'm going to get 1. Alright, so if I just were to put this into my calculator, all I'm going to do is just add all these numbers together. So I'm going to get 0.3 plus 1.5 plus 1, that's going to give me 2.8. Okay, so that's the expected value. Okay. So or the mean, mu, okay? Okay, so that's going to be it for part A. So for part B, let's say we want to find the expected value of x cubed. Okay, so if we want to find the expected value of x cubed, if you remember, in order for me to do something like this, I would have to take the x values and I'm going to have to cube them. So I'm going to do x cubed times p of x. So now every single x value that I have, I'm going to cube it, raised to the power of 3. And then I'm going to multiply by the probabilities and then add them. Okay, and this is going to be 0.2. So this is just still going to give me 0.3. 3 to the third power is going to give me 27 times 0.5. And 5 to the third power, that's just going to be 125 times 0.2. Okay, so now I'm going to put this into my calculator. So I'm going to get 0.3 plus 27 times 0.5 plus 125 times 0.2. Okay, and what I'm going to get is 38.8. Okay, that's going to be my answer for that. Okay, so that part A was the expected value. Part B was finding the expected value of x cubed. So now let's say for part C, what I want to figure out, I want to find the expected value of 2x cubed minus x plus 4. So let's say I wanted to figure out what that was. So using the properties of expectation, I can go back up and notice that what I can do, I can just, instead of trying to calculate something that's really, really complicated using this probability distribution, I can just use the properties, the linear property of the expectation. So this is just going to be finding the expected value of 2x cubed minus the expected value of x plus the expected value of 4. So I'm just taking every single term and I'm taking it with the expected value. This is going to be equal to 2 expected value of x cubed minus expected value of x, and then the expected value is just a number, it's just going to be itself. So I have 2 expected value of x cubed, well that's just what we solved in part B, that's just going to be 38.8. Okay, minus expected value of x, that's what we solved in part A, right, that's just going to be 2.8. And then I'm going to add it to 4. Okay, so I'm going to use all of this information. So 2 times 38.8 minus 2.8 plus 4 and my answer is going to be 78.8. Okay, so that's that problem. Okay, all right, so that's with expected value and using different properties. Now let's say for part D, I wanted to figure out what the variance is. So what is the variance of x of this probability distribution? Well, the variance, which is sigma squared, this variance is equal to the sum of x squares times the p of x minus mu squared. So that's the formula. Okay, so what I'm going to do, I'm going to take every single x and I'm going to first square it. So I'm going to take every x. What color should I use? I'm going to use this one. So every x, which was 1, 3, and 5, and I'm going to square it. 1, 3, and 5. I'm going to square them. That was our x. Then every probability, I'm going to multiply it, okay, to the x squared. So that's going to be 0.3, 0.5, and 0.2. 0.3, 0.5, and 0.2. So this summation means that I'm adding everything. All right, and now that I multiplied each x times the probability, I'm going to subtract this mu squared. So minus mu. Now what's mu? Well, mu was the expected value. This thing was oh no, not this one. This one was my mu. Okay, oh, there should be a 3 there. All right, this one was my mu. Okay, so this is just 2.8. Okay, so I'm going to get 2.8, and I'm going to square this. Okay, so I'm going to go ahead and put all of this into my calculator. Okay, so 1 squared times 0.3 plus 9 times 0.5 plus 5 squared, which is 25, times 0.2 minus 2.8 squared. Okay, and what I'm going to get, I got 1.96. Okay, I hope I did this right. All right. Okay, so now that I have that was the variance of x. So this is variance. Now let's say my next problem, part D, or I'm sorry, part E, says I want to find the standard deviation of 3x minus 4. Okay, that's what I want to figure out. Well, the standard deviation, if you remember, SD of x, which is sigma, is going to be equal to the square root of the variance. Okay, now we quite do not want that. We do not want x. What we want is this 3x minus 4. So the standard deviation of 3x minus 4 is going to be equal to whatever the square root of the variance of 3x minus 4 is. So what I'm going to do, I'm going to first have to find out what is the variance of 3x minus 4. Okay, so right now I have variance of 3x minus 4. All right, so one of the properties of variance was that I can take out the 3, right? So the 3, I can take it out, so that's going to be, but when I take it out, I'm going to square it, then take the variance of x. And now this 4 is going to go away, because if you go back to the properties say that when I take the variance, this b term, this extra constant, is just going to go away. The variance of a number is just 0. Okay, so what we're going to do, 3 squared is going to give me 9. Variance of x. Now what was the variance of x? Well, variance of x was just equal to 1.6. So this is 9 times 1.96. Okay, so I'm going to go ahead and take the multiplication. 9 times 1.96. That's going to give me 17.64. Now that's not quite what I want. What I want is not the variance of 3x minus 4. I want the standard deviation of 3x minus 4. Well, that's just going to be the square root of the variance of 3x minus 4. Okay, so, and I know what that is. That I just calculated that. That's just 17.64. All right, so let's see what this is going to give me. So I'm going to take the square root of 17.64, and what I'm going to get is going to be 4.2. Okay, so that is my standard deviation. All right, so I will do another problem that's a little bit more involved with the standard deviation, but hopefully this helped clear up a couple things.